types of chemical reactions. Types of chemical reactions. So basically this chemical reactions, there are so many classifications to talk about it. If you look at inorganic chemistry, over there we classify the chemical reactions based on mechanism into combinations, decompositions, single displacements and double displacements. And if you look at the concept of oxidation states, you classify chemical reactions into oxidations, reductions and redox reactions. So based on different points, you can bring out different classifications for the reactions. And according to the reversibility, we can also classify reactions into reversible and irreversible reactions, right? But right now we are talking about classification of chemical reactions based on reaction mechanism. And this particular classification is only concerned with organic reactions. So organic reactions can be classified based on the reaction mechanism, based on how exactly a reaction turns into product into 4 types. There are 4 types of chemical reactions. The first one is addition reaction. The second one is substitution reactions. The third type is elimination reactions, and the fourth type is rearrangement reactions. So basically we are talking about the types of chemical reactions based on organic reaction mechanism. Based on organic reaction mechanism, organic reactions can be of 4 types: additions, substitutions, eliminations and rearrangements. Let's understand what is meant by each of them one after other. Let's get started with the first one, addition reactions. So over here, observing the word is very much different. If you observe this word, you will understand the definition to some extent already. So over here, additions, the kind of additions that we talk about in mathematics, we are still talking about the very same thing. When you have 2 atoms or when you have 2 molecules being added to each other, you call it as addition reaction. So you can call it as like A plus B gives you AB kind of reactions. So when you are adding a molecule to the given organic sample or given organic substance, you consider this as addition reactions. But all the reactions cannot be additions. There are some conditions for having the addition reactions observed, of which the first condition is addition reactions require presence of at least 1 double bond or 1 triple bond. The organic molecule should contain at least 1 double bond or 1 triple bond so that addition can occur. And the second thing is addition reactions are not possible with saturated hydrocarbons. If you are talking about any saturated molecule, if you're talking about a molecule containing only single bonds, additions are not at all possible over there. So the conditions for addition is presence of unsaturated molecules. But why? Why is it needed that you have an unsaturated molecule to have the addition happening? So basically addition is when you add a molecule to the existing molecule, right? And in order to have a molecule added to the other molecule should have that capacity to accommodate the newer atoms. Let's take an example to get this better. I'm talking about CH2 double bond CH2. This is basically an unsaturated hydrocarbon. And in this unsaturated hydrocarbon, there's a double bond. What does this mean? Why is this double bond formed? This double bond basically is formed because the carbon atoms were not having any other atoms to combine with. So they compromised and they adjusted with each other to form a double bond so that they partially attain stability. But this double bond's presence is not something satisfying to carbon atoms. They always would want to attain single bonds. So now when I have one such double bond and when I'm trying to add an atom or a molecule to this double bond, because double bond anyways is not stable, it would break down and the hydrogens that I have added will be substituting the double bond in this way, leading to formation of CH3 single bond CH3. Now why did an addition reaction occur? The addition reaction occurred because there was space, there was a place, there was a scope in the molecule to have the new bonds formed. And in case I'm having a molecule like this, CH3 single bond CH3, both the carbon atoms are having 4 single bonds. Single bonds is like ultimate stability in terms of carbon. When carbon has 4 single bonds, it doesn't have capacity to have any other atom added. It's already at the peak of its stability. It doesn't have scope or capacity to invite anybody else into the molecular structure. So here, if you are trying to add hydrogen, there's no space. When there is no space to get added, the reaction doesn't happen. So double bonds on triple bonds break down in order to accommodate the newly added molecules. They are like space that is present in the molecule to accommodate the newly added species. So addition reaction is when you add a molecule to unsaturated hydrocarbons and it results in conversion of unsaturated hydrocarbons to saturated hydrocarbons at times. So you can convert unsaturated hydrocarbons into saturated hydrocarbons through this addition reaction. And you can add any simple molecules, like for example, you can add hydrogen. And if you're adding hydrogen, you call the reaction as hydrogenation. If you're adding chlorine, you call it as chlorination. And what if you are adding water, H2O? If you're adding water, you call it as hydration. So the term ATION, Asian, is added to these addition reactions like hydration, chlorination, hydrogenation, fluorination, bromination, etc., etc. Let's take examples for these 3 reactions to understand it better. I'm taking a carbon-carbon double bond and I'm trying to add hydrogen to this double bond. And when I add hydrogen, this double bond breaks down and you will be having a new hydrogen added to both the carbon atoms. So hydrogen added here and hydrogen added here. You call this as hydrogenation. Instead, if you add chlorine to the same molecule, then you will be having carbon containing 2 chlorine atoms, chlorine 1 here and chlorine 2 here. You call it as chlorination. And in case of hydration, you have added H2O rather. This gives you carbon-carbon single bond with a hydroxy group at one carbon and a hydrogen at other carbon. This way you can add any molecule of your choice and you call these reactions as addition reactions. We for time being have taken example of a double bond. Rather, you can take an example of triple bond also. For example, carbon-carbon triple bond, and I'm trying to add 1 hydrogen molecule. 1 hydrogen molecule is how many atoms? 2 atoms of hydrogen. So I'll add 1 atom here, 1 atom over here. And in order to add 2 atoms, you would have to be breaking 1 bond. If you want to break 2 bonds, you should be adding how many? 4 atoms together. Because I have only 2 atoms over here, I can break 1 bond out of the 3 bonds that I see. And this leads to formation of CH double bond CH, a new hydrogen added at both the places. And now because I still see a double bond over here, if I want to break this double bond, I should be adding 2 more atoms of hydrogen. Here is 1 and here is 1. This leads to formation of CH3 single bond CH3. And also remember, these addition reactions do not happen always at ordinary conditions. You would have to be supplying the suitable conditions. For example, if you want to add hydrogen, you would be needing a catalyst to conduct the reaction. You also would be needing high temperatures. But if you want to add chlorine, it can happen at better conditions. It can happen at nominal conditions. If you want to add water, still you have to maintain some special conditions. All of these chemical reactions that you are talking about might require some or the other reaction conditions according to their stability, etc. points. Okay? So this is the first type of organic reaction, addition, where you are having either double bonded or triple bonded hydrocarbons being involved in the reaction.